Okay, Assalamualaikum and good day everyone. So today we are going to start with our first lecture for this chapter, number system and equation. Okay, the first subtopic of this chapter is real number. And the second one is the indices, surds and logarithm. So we are going to focus on these two subtopics, and shall we start with the learning outcome? So at the end of the lesson, students should be able to, the first is to define the natural number, whole number, integers, prime numbers, rational number, and irrational number. Okay, so we represent natural number as n, whole number as w, integers as z, prime numbers, rational number as q, and irrational number as q bar. And then the next one is to represent the relationship of number sets in real number system diagrammatically, showing that n is subset of w, subset of z, and subset of q. What is q? Rational. And q, the rational is the union with irrational. We will get the real number. Represent open, closed, and semi-open intervals and their representation on number line. And the last one for 1.1 is to find the union and intersection of two or more intervals with the aid of number line. Okay, for 1.2, for this lecture, we are going to focus on A. Express the rule of indices, B. To explain the meaning of surd and its conjugate, and C. To perform algebraic operation on surd. So we are going to focus into two things only, which is indices and surd. So what is natural number? So you've learned this since high school. So natural number is just a set of counting numbers. So how do you count your apple? How do you count the stars? How do you count your grade? Yes, it starts with 1, 2, 3, 4 and so on. And then we have prime number in the natural number. Why? Prime numbers means that the number in the natural number itself greater than 1 and can be divided by 1 and itself only. Means that it cannot be divided by other numbers. For example, 2, 3, 5, 7. How about 9? 9 is not a prime number because we can divide it by 3. Do you know what is the whole number? So whole number is actually the natural number together with the number of 0. So we just add up 0 in the natural number, so we get the whole number. So it's 0, 1, 2, and 3 and so on. The integers, the whole number together with the negative of counting number from the set of integers denoted by z. So we have the whole number 0, 1, 2, 3 and include the negative of the counting number. So negative 1, negative 2 and 3, negative 3 and so on. Okay, so integers can be separated into negative integers, positive integers, and 0. And integers, we can represent it as two different numbers, which is the odd numbers and even numbers. So what is odd numbers? So any value of k in integers, if we multiply by 2 and plus with 1, we get the odd number. Or minus 1. So for even number, it's only 2, the double of the value of k. So 2k. Rational number. A rational number is any number that can be represented as a ratio or quotient of two integers and can be written as q is a rational number is equal to a over b, where a and b is an integer where b cannot be 0. Why? Because a over 0 is not defined. Okay, so how do you represent it as a fraction? So what are the examples of rational number? So ratio or quotient or fraction. So for example, we have 1 over 2. Okay, 3 over 4. So all of these are the rational number. Is it only in the ratio form, quotient or fraction? No, it also can be represented as a decimal. So how do we detect that it is a rational number? It should be a type of terminating or repeating decimal. So what is terminating? Means that the decimal stops at some points. It will not continue up to infinity. For repeating decimal, the decimal will repeat the numbers. It can be repeating 1 or repeating 2 or repeating 4 numbers. So let's see the example. So here we have 8 over 1. It's a fraction. We can represent 8 as a fraction. So it is a rational, and it is also the natural number, right? And then how about 2 over 5? 2 over 5 is a fraction, so it's a rational. So it can be represented in the decimal, which is we get 0.4. So this is terminating. We don't have any more decimal beside the 4. And the next one is 4 over 11. So if you use the calculator, you will get 4 divided by 11 equal to 0.363636363636. So it will continue. It's not stopping. We have the 11 decimals in the calculator, but if we see it, it will continue with the number 3636 and so on. So this is what we call as repeating decimal. It will repeat this two number 36. For example, another example is negative 19 over 3. It will be negative 6.33333333. So what are they repeating here? They will repeat 3. Okay, irrational number. So it will be opposite of the rational number. So this irrational number is not rational. Okay, so cannot be written as a quotient or fraction or ratio, and it is not a repeating decimal or not a terminating decimal. Example, we have set 5 equal to 2.23606797 and so on, and pi 3.14159 and so on, and exponent 2.71828182845 and so on. So this is the way how to differentiate the irrational and irrational. So this is a fraction. This cannot be written as fraction, and this is repeating decimal. This is terminating decimal. This is not repeating. This is not terminating. Okay. Numbers that either rational or irrational are called real number. So in real number, we have two groups. The first one is rational, another one is irrational. But in rational number, we have another groups. So this is what we call to represent the relationship between the sets of number. Okay, so Venn diagram. So we use Venn diagram to represent their relationship. So we have two types of number in real number. The first one is rational. The second one is irrational. Okay. So this is rational number, this is irrational number. So inside the rational number, we have the natural number, the integers, and then inside the integers, we have the whole number, and without zero, it will be the natural number. So combination between these two sets, rational and irrational, we get the real number. That's why we have natural is a subset of whole number, and whole number is a subset of integers, and integers is a subset of the rational. Okay. And rational union with irrational, we will get the real number. So real number divide into two, we get rational and irrational. Rational can be represented as fraction and this is the example, and the repeating or terminating decimal. So separating into the next step, we have integers and the fraction. So the remaining will be the fraction, because it can be represented as fraction. So integers is the value that divided by 1, the fraction that divided by 1. And then for the integers, we can separate into two, which is we have the whole number and the negative integers number. And in whole number, we can separate into two with a natural number and 0. Okay, so this is how we categorize all the numbers in the real number. Okay, let's do some examples. So let's say we have a set of number s is equal to negative 9 square root of 7, 1 over 3 pi 0, 0.13 bar 6, and 8.121212. Identify the set of natural number, whole number, integers, rational, irrational, real numbers. Okay, so which one is the natural number? So we have the one that don't have any point or fraction is 0 and 6. So is 0 a natural number? Nah, we have 6 only. So 6 should be the only natural number. How about the whole number? Then we can include 0. And then integers, the value that we have negative. So include the negative 9. Okay, so it should start from negative 9, 0 and 6. Including the whole number lah. And then the rational number, the one that we can write in the fraction or terminating decimal or repeating decimal. Okay, so which one? So it will be the negative 9 and then square root of 7? Nah. 1/3 in the fraction form, pi, not. And then 0, 0.13 bar because it's repeating the 13. And then 6, how about 8.1212? So if we see here, it will be repeating because we have dot 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 there. So it will be 8.1212. How about the irrational number? The only numbers that we didn't include is square root of 7 and pi. So these two should be the irrational number. And the last one, the real number. So we have to include the rational and irrational together. So everything here it will be the rational number, the real number. So negative 9, square root of 7, 1/3, pi, 0, 0.13 bar, 6, 8.1212. Okay, so let's check the answer. So all correct. Good. So next part is the number line. So the set of numbers that correspond to all points on number line is called the set of real number. So what we are drawing, the number line, is actually all the real numbers lies on the lines. So this real number included irrational and rational. So we don't know exactly what is all these numbers. That's why we represent it as a line. For example, it can be 0.00001. It can be 1,000, 1 million, and so on. So if we represent it on number line, it will be easier because we don't have to state all the values. Okay. The real numbers on the number lines are ordered in increasing magnitude from the left to the right. Means that the most negative should be on the left side, the most positive will be on the right side. For example, negative 3.5, 2/3 and pi can be shown on the real number as, so negative 3.5 in between negative 4 and negative 3, and then 2/3 is in between 0 to 1. So all of these are real numbers. And also pi, even though it's irrational, it's still a real number. So we don't know what is the exact value of pi. It's only 3.142 and so on, right? So we cannot exactly pin out where is the value lies. Symbol. So we have A equal to B. Let's say these two numbers are the same. 3 and 3 are the same, right? So A less than B means that, for example, negative 4 should be less than 4 lah. And A more than B will be 5 is bigger than 0. So the symbols less than or more than are called inequality sign. So all sets of real number between A and B where A less than B can be written in the form of interval as shown in the following table. So there are several types of interval. Closed interval. How to represent a closed interval? Yeah, we represent in the form of square bracket. Means that we include the value A and B. So we have inequality sign with equal sign. So less than or equal to. And then on the number line, we can represent it as the dense dot, or we can draw it as a full circle. Okay, so this is, and connect the 2 points. The open interval, so we represent it as round bracket of A to B. So we only have less than A less than X less than B. And then how to represent on the number line? So we have the empty dot, just a empty circle, and then connect the 2 points. So it can be half closed or half open. So we call it as semi-open interval or semi-closed interval. So it can be the left side is open, the right side is closed, or the left side is closed, the right side is open. So this one we only have equal sign on B. So at A we have the empty dot or empty circle, and on B we have the dense dot. So the other one is here, empty on the B, close on the A. So we have equal sign on A, so we can represent is dense dot on A, empty dot on B. So open interval, so it can be from negative infinity. So we can represent in the interval form from negative infinity to B, both open, and then we have this inequality, or x also can be written as x less than B only. Okay, so the value here is x less than B. So we don't have to write down this. We only know the x is in between negative infinity to B. Semi-open interval, so the same one, but we have the square bracket here. Open interval, semi-open interval, the same as number 5 and 6. The simple infinity is not numerical. When we write a to infinity, we are simply referring to the interval starting at a continuing indefinitely to the right. So it's infinity. Okay. Intersection and union. So intersection and union operation can be performed on intervals. So for example, we have these two sets, set A from 1 to 6, where 1 must be included, and B from negative 2 to 4, both are excluded. So how to find? We can represent both of this set on the number line. Okay, so it's from 1 to 6, dense dot at 1, empty dot at A, and then empty dot at negative 2 and 4. So we have two sets A and B. If the question asks you to find the intersection, so we can find the area that has both sets. So where is the area that has both sets? Here. So it has on A set and also on B set. The intersection between set A and B is given by, so it starts from 1 to 4, where 1 must be included, 4 is not included because 4 is not in the set B. Okay. How about the union? So the union, we just take everything on A and B together. So the smallest value here we have is negative 2, and the biggest value we have 6. So it should be negative 2 to 6. Both are open dot. So example to solve from 0 to 5, where 0 included, union with 4 to 7, open interval, and intersect with closed interval of 1 to 8 using the number line. So because we have two operations here, usually we do the left side first, the one we meet first. Okay, so we draw the number line. Start off for the first one. So we have 0, 5, 4, 7. So it will be continually following the order will be 0, 4, 5, 7. So draw the set number. So from 0 to 5, that's the at 0, empty dot at 5, and then from 4 to 7, both are open. Okay, so where is the union? So we must include both the union together. Okay, so we start from 0 up to 7. Okay, so the answer should be close bracket from 0 to open bracket to 7. So the answer for the next one is 0, 7. And then we continue with the next operation, which is intersection with 1 to 8, close interval. So we draw the another line. So we have 0, 1, 7 and 8. Label it increasingly. So from 0 to 7, semi-open interval, and from 1 to 8, closed interval. So where is the intersection? So both the one that has on both sides. So we have 1 to 7. So 1 we include on both sides. So we have the close bracket for the 1. How about 7? We don't have 7 on the first side, so empty dot. So that's why the answer is close bracket at 1, open bracket at 7. Okay, so now we continue with the next subtopic, which is the indices. So indices is in SPM syllabus for the math. So what is indices. So let's say we have a 2 multiply with 2 multiply with 2 multiply with 2 multiply with 2. So if we see here, it's actually 2 being multiplied for 5 times, right? So we can write down this as 2 to the power of 5 because these 2 are repeated by 5 times. This is known as the power. Sometimes we call it as exponent or index. A to the power of x is written as A subscription of x. So A to the power of x is an expression in which A is the base and x is the power. So A is the base, x is the power. Rule of indices. This is important in solving the indices equation. So the first one, when a to the power of m multiplied with a to the power of n. So what we notice here that we have the same value of base, which is a. So we can write down, simplify this multiplication into is equal to a to the power of m plus n. The second one is when a to the power of m, we power up to n. So this a to the power of n multiplied by n times. So we have am multiplied by am multiplied by am for n times. Okay, so we can actually write down as a to the power of the index multiply each other. So a is equal to m multiplied by n. The second one is, so the first one we have multiply, the second one we have division of a to the power of m with a to the power of n. So it's divide. So when divide, what it will be? Yes, it will be a to the power of m minus n. Why? Because this division is actually equal to a to the power of m multiplied with a 1 over a to the power of n. So what is 1 over a to the power of n? Okay, so we will see later. Number 4, a to the power of 0 is equal to 1. So a multiplied by 0 times, so it will be 1. Any number to the power of 0 is equal to 1, where a cannot be 0, the base cannot be 0. And number 5, a to the power of negative m is actually equal to 1 over am. Okay, means that this is the same as the number 3. So this 1 over a to the power of n can be written as a to the power of m multiplied with a to the power of negative n. So applying the first rule, what do we get? We get a to the power of m plus minus n. So plus minus is actually just minus. Okay? Okay. And the last one, a to the power of 1 over m is equal to the root of m of a. So it can be any value lah, this m. So number 7, so we have here a to the power of m over n equal to root of n of a to the power of m. Or we can write down as a to the power of 1 over n to the power of m, or a to the power of m to the power of 1 over m, which is root of sorry. Okay, let me clear this up. So it should be what? Yeah, a to the power of m to the power of 1 over n, which is this 1 over n is actually root of n. And number 8, ab all to the power of n means that a multiply b all to the power of n. So we can put the index on both base. Okay, the first rule we have same base with the different power, but for this one we have the different base with the same power. So it's actually a to the power of n multiplied with b to the power of n, which is a and b to the power of n. There are some special cases to consider. So division when powers are equal. So we will have 0 index. Because 6 power 4 minus 4 here is equal to 0. 6 power 0 is equal to 1. This result leads to another rule, which is 8 power 0 equal to 1. Division when the power of the denominator is greater than that of the numerator. So the final answer will get the value with the power of negative. So what do we do here? Yes, this is going to the fourth or fifth in rules. Okay, a negative power indicates a reciprocal. Rational index. So rule 1 can be used to introduce rational power. Suppose that m equal to n equal to 1 over 2 in rule 1. So 8 power of 1 over 2 multiplied with 8 power of 1 over 2 equal to 8 power of 1 over 2 plus 1 over 2. So it will be 8 power of 1. Okay. Means that 8 power of 1 over 2 equal to square root of 8. The meaning of power 1 over 3 can be established in a similar way. Okay, so 8 power of 1 over 3 multiplied by 3 times, so we have 8 power of 1 over 3. If we power it to 3, we get 8 power of 1, which is equal to 1. Means that 8 power of 1 over 3 is equal to cube root of a. This means power 1 over 3 implies a cube root. Investigate power 1 over 4 and 1 over 5 and so on in the same way. Notice how the fraction is related to the root. So, let's do some example. Simplify each of the following expression. So we have 21x squared y to the power of 5 divided by 3x4 multiplied by y. And question number B. So let's do question A first. So let's do question number A first. So what we can do for the value here, we can just directly use the simple operation, right? So we get 7. How about x? So we have the same base x and same base y. So do the operation for x and y. So we have x power of 2. So divide will be minus. So x power of 2 minus 4 and y to the power of 5 minus 1, because divide by y means that y to the power of 1. So what do we get here is 7 of x to the power of negative 2 and y to the power of 4. So that's for question number A. For question number B, so we have 2 to the power of 2n plus 4 minus 24 multiplied by 2 to the power of 2 of n minus 1. And we divide with 10 of 2 to the power of n all square. Okay, so what we can do here, so applying the rule of indices, this addition can be changed into the multiplication between the two same base. So we have 2 to the power of 2n plus 4 will be 2 to the power of 2n multiplied by 2 to the power of 4. And then for this one, negative 24 multiplied by 2 to the power of, this is 2n minus 2. We expand here. So we get 2 to the power of 2n multiplied by 2 to the power of negative 2. So if you notice here, we have 2 to the power of n on both. 2 to the power of 2n. Here is 2 to the power of n to the power of 2 can be written as 2 to the power of 2n. So actually we can factorize the 2 to the power of 2n and yes, we can eliminate 2 to the power of 2n. So what do we have on the top? We have 2 to the power of 2n multiplied with 2 to the power of 4 minus 2 to the power of 2n. We take out already. So we have 24 multiplied by or divided by 2 to the power of 2, which is equal to 4 divided by 10. So what do we have here? This 24 minus 4 is equal to, divided by 4 is equal to 8. 2 to the power of 4 is, what is 2 to the power of 4? 24 divided by 4 is 6, sorry. 2 to the power of 4 is equal to 16. So 16 minus 6 is equal to 10, and then this is 2 to the power of 2n, and at the bottom we have 10 multiplied by 2 to the power of 2n. Okay, so if you know, you can repeat again, or let me restart the explanation for question B. So what we have here is the same, the common, factor of 2 to the power of 2n. How? We get it by separating using the first rule. Okay, so here we have 2 to the power of 2n, and 2 to the power of 4 is equal to 16 minus 24. This is 2 to the power of negative 2 is equal to 1 over 2 to the power of 2. So we have 24 divided by 4 equal to 6 of 2 to the power of 2n. So at the bottom also we have 2 to the power of 2n to the power of 2, which is equal to 2 to the power of 2n. So what do we have after we factorize 2 to the power of 2n? We get 16 minus 6 over 10 multiplied by 2 to the power of 2n. So this is equal to 10. So 10, 2 to the power of 2n, 2 to the power of 2n is equal to 1. Okay? Okay, so the next part in this subtopic is surd. So what is surd? A surd is an irrational number that contains square root of a positive value. Square root, positive number, which is not a perfect square. It can be a monomial or binomial. What are the examples of perfect square? Square root of 4, which is equal to 2. Square root of 9, which is equal to 3. So these are the examples of perfect square. So it should be not a perfect square. That is, the square root b is a monomial surd where b is a positive and not a perfect square. And a plus square root of b is a binomial surd where b is a positive and not a perfect square. Rule of surd. So the first one, it should be the square root of a b is equal to square root of a multiplied with square root of b. So actually we can just assume it's really the same thing. Square root is equal to, surd is actually equal to square root because it's square root of the positive number, right? So if it's square root, means that this value is actually equal to a to the power of 1 over 2. Means that the power is always 1 over 2. So what we have here is actually a to the power of b to the power of 1 over 2. So if we apply the rule of indices, so we have here a to the power of 1 over 2 multiplied with b to the power of 1 over 2. So it's just the same as indices. So you don't have to being confused or feel that it's really hard or anything. It's really simple. Just relate to the indices, so it will be easier for you. Okay, so the second rule is square root of a over b equal to square root of a divided by square root of b, or surd. Okay, we can use the term surd. Okay, this is actually the same as a over b all to the power of 1 over 2. So we can separate it into a to the power of 1 over 2 divided by b to the power of 1 over 2. So the next one is a square surd b plus c surd b. So let's say we have the same surd b here. So it's like b is an x, surd b is an x. So ax plus cx. So what do we get? Yes, we can factorize the x out. So it will be a plus c of x. That's why we have what we have here. Yeah, it will be a plus c of surd b. Okay. The next rule is a surd b minus c surd b. The same as c will be a minus c surd b. Additional rule. Surd a multiplied by surd a is equal to surd a square equal to a. Why? Will be a to the power of 1 over 2 multiplied by a to the power of 1 over 2, which is equal to a to the power of 1 over 2 plus 1 over 2, which is a to the power of 1. And then surd a plus surd a is equal to 2 of surd a. So this is 1 of surd a plus 1 of surd a. It's like 1x plus 1x equal to 2x. And then surd a divided by surd a is equal to surd a over a, which is we get surd 1, which is equal to 1. Right? And then for number 4, in a bracket of surd a plus surd b all to the power of 2. So what we do here is we expand. So surd a plus surd b multiply with surd a plus surd b. We expand as usual. So surd a multiplied by surd a, we get a. set B multiplied by set B, we get B. And then set A multiplied by set B, we get set AB. And then set B multiplied by set A, we get set BA or set AB. That's why we get A plus B plus 2 of set B. Okay? And then the next one. Oh, this is the just explanation. So the same as the one that I do earlier. Oh no. This is for set A plus set B multiplied with set A minus set B. So what do we get here? This in between, in the middle here will be cancelled out. So we only have A minus B. So remark here that set of A plus B is not equal to set A plus set B. We cannot assume it's the same. No, it's wrong. Let's do some examples. So express the simplest form. 3 set 6 multiplied with 5 set 7. So what we do, we just do the number, the usual number, do the operation together, and then the one on the set, under the set we do this operation together. So what we do have here, we have 3 multiplied by 5, which is equal to 15, and square root of 6, set 6 multiplied by set 7, apply the rule of indices, multiply, we just multiply the value here. So we have set of 42. And then here we have 8 set 2 multiplied by 5 set 6 plus set 2. So we just expand as usual. So we have on the first term will be 8 multiplied by 5. So we get 40. We get 40, and then the one in the bracket, in the set 2 multiplied by set 6, we get set 12. And then the next term is 8 multiplied by set 2 multiplied by set 2 equal to 8 set 4. So what is set 4? Is equal to 2. So 2 multiplied by 8 is 16. Okay? So what they do here, they simplify the 12, because 12 is a factor of 4 multiplied by 3. So if we apply the rule of set, we get set 4 multiplied by set 3, which is set 4 is equal to 2. So set 4 is equal to 2 multiplied by 40 is equal to 80, set 3 plus 16. So that's for question C. And then for the question, so question B, for the question C, this is the same as the one in the remarks. Okay? We expand as usual. So what do we get here? And lastly, we get 8 minus 3. Believe me. So equal to 5. You can refer to the remarks before. So conjugate set. The sum and difference of two simple quadratic sets are said to be conjugate set to each other. Conjugate sets are also known as complementary sets. It can be used to express a fraction which has a compound set as its denominator with a rational denominator. Okay, so let's see what it means by conjugate. You multiply the top and bottom of a fraction by the conjugate to what? To eliminate the set. Okay, because we can represent it as a denominator. If we have set in the denominator, so it's not a nice representation. Okay, so in general, two binomial quadratic set, so we should have x set A plus y set B, and then the conjugate is actually x set A minus y set B. So here are some examples of conjugate in the following table. So set 2, what is the conjugate? So we put negative there. Set 2, no, because it will be negative 0 there. Okay, so set 2 multiplied by set 2, it will eliminate the set. So we just need to put sign on the 1. So this is set 2 plus 0, this is set 2 minus 0, so which is the same. And then this one 3 plus set 2, so we can change the sign of one of it, which is 3 minus set 2. For 3 minus set 2 will be 3 plus set 2. Set 3 plus 1, set 3 minus 1. So it doesn't matter which one we should put. We just put the sign, change the sign on the back. Whether it's on the set or not, it will be okay. Now, why we need to rationalize? So if we notice all this question, all of it have denominator with sets. So this is not a good representation of that number. Okay, we need to eliminate any sets on the denominator. So here, what we need to do, we have to multiply with the conjugate of the denominator. Okay, let's do question A. So square root of 17 minus square root set of 17 minus set 5 divided by set 17 plus set 5. So what we need to do, multiply with the conjugate of the denominator, which is equal to set 17 minus set 5. So this value should be multiplied with the numerator, also the denominator. Okay, we use the conjugate of the denominator only. Okay, now, so how to do this one? Don't forget to expand everything, not just multiply with set 5. So you have to expand. Okay, so what do we have on the numerator? So we have set 17 multiplied by set 17, and then we have negative set 5 multiplied by set 17. We have negative 17 set 5, and then set 17 multiplied with negative set 5. So we have negative set 5 set 17, and then the last one, negative set 5 multiplied with negative set 5. We get positive of set 5 squared. Okay, so how about the denominator? Directly we will get this a squared minus b squared. What is our b? It's set 5. What is our b? A is set 17. That's why we get square root of the set 17 square minus set 5 square. So we have 17 minus 5 in the denominator. So what do we have in the numerator? So set 17 square is 17, plus with set 5 square is 5, and then here 17 and set 5, set 17, set 5, we have 2 times, so minus 1 will be minus 2 of set 5, set 17 divided by 12. So simplify the numerator, we get 22 minus, so multiply 5 with 17, we get 85. So 22 minus 2 of set 85 divided by 12. Okay, so for question number B, 1 plus set 2 divided by 1 minus set 2 plus with 1 minus set 2 divided by 1 plus set 2. So how about this one? Do we need to multiply with the conjugate of the denominator for both of the fraction? Okay, we might consider to just directly find the common denominator. Why? Because the denominator of both fractions are conjugate of each other. Okay, so what I need to do, we just multiply the denominator 1 minus set 2 and 1 plus set 2, and then don't forget to multiply with the numerator for each of these fraction. So we have 1 plus set 2 on the first fraction, it should be multiplied with 1 plus set 2, and then the second fraction is 1 minus set 2, it should be multiplied with 1 minus set 2 also. Okay, now we just have to simplify the numerator. So we get 1 plus set 2 plus set 2 plus set 2 square, and then minus of 1 minus set 2 plus set 2 square. How about the denominator? Directly we expand, we get 1 minus 2, right? So what do we have on the top? We have 1 plus 2 minus 1, so 1 plus 2 plus 2 times of set 2, and then here we have minus, right? So we expand it. Why minus? Is plus lah here. Yeah, this one is plus, not minus. This is plus. So we shouldn't be confused. So plus with 1 minus 2 times of set 2, and then plus with 2 divided by negative 1. So this 2 set 2 can be cancelled out with negative 2 set 2. So 1 plus 2 plus 1 plus 2 is equal to 6. So 6 divided by negative 1 should be equal to negative 6. So this is the first method you can do. Or what you can do, we can multiply with the conjugate of the denominator for each of the fraction first, and then we do as usual. So this one, because I want to do directly, because we know that the denominator, they are conjugate with each other. So let's see the second method to solve this question. Okay, so the second method, we do multiply with the conjugate of the denominator for each of the fraction. So solve it separately. So what do we get on the left side? We get 1 plus Z2 plus Z2 plus 2 over 1 plus Z2 minus Z2 minus 2. And then the right side, we get 1 minus Z2 minus Z2 plus 2 over 1 plus Z2 minus 2 minus Z2 minus 2. Okay, so simplify everything, we get 3 plus 2 Z2 divided by negative 1. And the right side also 3 minus Z2 over negative 1. So combine together, here we get 6 over negative 1. Right? So we will be the same answer, which is negative 6. Which one is easier? I thought the first one is easier. Okay, because why? Because it's conjugate with each other. If not conjugate with each other, then it will be longer lah. So you have to do the second time multiplication of the conjugate. Okay, so it's depend on the type of the denominator. So for question C, the last question. So what do we have here? Z3 plus Z2 divided by Z3 minus Z2 plus Z2. Okay, so we have the Z2 here on the right side beautifully, so don't do anything with it. What we need to do is to simplify the one with fraction. So what we need to do is to multiply with the conjugate of the denominator, which is Z3 plus Z2. Multiply both on the numerator and the denominator, and then plus Z2 on the right side. So what we need to do? Expand as usual. So don't forget this, we have bracket. You need to expand, don't just multiply with one terms. So expand as usual. So what do we have on the numerator? We have Z3 multiplied by Z3 will be 3. Z2 multiplied by Z3 will be Z6. Z3 multiplied by Z2 will be Z6. And Z2 multiplied by Z2 will be 2. And the denominator will be 3 plus Z6 minus 2, which is this can be cancelled out. So we have plus Z2 on the right side. So what do we have on the numerator? Yes, we have 3 plus Z6. No, 3 plus 2 will be equal to 5 plus 2 times of Z6 divided by 3 minus 2, which is equal to 1. And then plus with Z2. So what do we have as the answer? 5 plus Z2 Z6 plus Z2. Can we simplify? No, because we cannot write down 6 as a multiplication with another numbers. You can. We can write down is as 3 and 2. 3 Z3 multiplied by Z3 multiplied by Z2. But what is Z3? It's nothing, right? We cannot simplify it, so we can just leave the answer as is it. Okay? Okay, so that's all for first lecture. Please try to understand the basic concept of the number system. Okay, bye. Thank you, class.